Hello, I'm Arthur Georges, and I'm going to give a brief 3-minute talk on AusARG, the Australian Reptile and Amphibian Genomics initiative of Bioplatforms Australia. Bioplatforms Australia has a range of strategic projects in response to national challenges. And basically their remit is to build large databases, build the associated infrastructure, build the capacity within Australia to use genomes to address the important questions for science, management and industry. Ours is just one of many projects that Bioplatforms Australia has initiated. Now, you'd know that Australia is an island continent, and that brings with it features that influence the biota. This long-standing isolation has led to a high level of endemicity. Progressive aridity has shaped the fauna. Climatic unpredictability also has been an important aspect of the Australian environment that the biota has to contend with. So this provides unparalleled opportunity to apply genomics to answer unique questions in Australia that are of global relevance. We set up some criteria for selecting projects. They needed to be relevant to questions of substance in conservation, management, or discovery more broadly. The team had to have the capacity to assemble, annotate, curate, and physically map using the latest technologies. They had to have the capacity to marshal funding, that is, to be Australian Research Council competitive. And they had to have access to the tissues for extracting high molecular weight DNA for long-read technologies. We also were very keen that at least some of the projects delivered platinum genomes that would serve as a national resource. Here are some examples of the projects. We have one on evolution of viviparity and placentation in skinks, one on sex determination in dragons and skinks, one on chromosome evolution in geckos, one on host-parasite interactions in the sleepy lizard, one on evolution of genome size in frogs, and one on marine transitions and venoms in the elapid snakes. So a lot of projects. Our assemblies are based on both Oxford Nanopore, ONT platform, backed up with Illumina short reads for polishing, and PacBio Hi-Fi. And we're getting really good assemblies from those two platforms. And that's indicated here by a comparison of the length of the chromosomes of the sleepy lizard determined by cytology and the length of the scaffolds that we're generating from the assembly, both from ONT and from the Hi-Fi assemblies. So good correspondence between the length of the scaffolds and the length of the chromosomes independently derived from cytology, perhaps with the exception of chromosome 5. We've sequenced the sleepy lizard with high C, but it's yet to be added to our assembly. Similarly with the dragon lizard, really good assemblies, very large contigs, and good evidence that we're getting chromosome scale assemblies. You can see even little microchromosomes have been assembled from these two techniques. Again, high C has been sequenced, but it's yet to be added. And we've been able to phase out the sex chromosomes, which is really important for us because it enables us to identify candidate sex-determining genes, to look at issues around dosage compensation and other aspects of sex determination that are of great interest to my team in particular. We've got some additional collaborations. There's one in particular with Inge Sim from the Nanjing University, and he's using ST-LFR, the BGI platform, plus IC to look at the genomics of adaptation to aridity in the agamid lizards. So we've got agamid lizards that live in rainforests all the way through to the arid centre of Australia. And I'd just like to finish up just acknowledging several people who are heavily involved in this work from the Garvan Institute, the ANU, University of New South Wales and Nanjing University. Thank you very much.